Let's open the Submodule 3 file. Submodule 3 focuses on sequence alignment and phylogenetic tree construction. We'll use MAFFT for alignment, explore algorithms like maximum parsimony and maximum likelihood, and build trees with tools like Usher and IQ-Tree. Let's take a quick look at the key sections. Sequence alignment. Sequence alignment organizes SARS-CoV-2 sequences to create accurate phylogenetic trees. We'll align sequences. FASTA from Submodule 2 using MAFFT. Code Cell 1, setting up the directory for MAFFT. This cell creates the data/COV/alignment directory. Let's run it. Directory created. Let's check the folder. Yep, it's right here. Code Cell 2, performing alignment with MAFFT. This cell aligns the sequences using MAF's auto option and saves the output to aligned_sequences.fasta. Let's run it. Depending on the file size, this may take about 15 to 20 minutes. Alignment completed. Ready for tree construction. Phylogenetic algorithms. This section covers maximum parsimony for speed, maximum likelihood for accuracy, and approximate maximum likelihood for balance. Nextclade. Nextclade checks sequence quality and prepares data. Let's run its workflow. Code Cell 3, making Nextclade executable. This step sets permissions for Nextclade. I'll run it. Permissions are now set. Code Cell 4, downloading Nextclade reference. Let's execute this. This downloads SARS-CoV-2 reference data to data/SARS-CoV-2. Let's check the data/SARS-CoV-2 folder. Here's the file. Reference files are downloaded. Code Cell 5, creating Nextclade folder. This creates a new folder called Nextclade if it doesn't already exist. I'll run it. Folder created. Code Cell 6, running Nextclade. Let's run this. This runs Nextclade, generating reports and a tree in data/COV/phylogenetic_tree/Nextclade. Let's open the Nextclade folder. I'm navigating to data, then COV, phylogenetic_tree, and Nextclade. Here are the executed files. Done in under a minute. Files like Nextclade_tree.nwk are ready for Submodule 4. VCF format and Usher. Usher uses maximum parsimony with VCF formatted data. Let's convert our alignment and run Usher. Code Cell 7, converting to VCF. Let's execute this. This converts FASTA to VCF, saving it as phylogenetic_tree_aligned_sequences.vcf. It takes about 10 seconds. VCF file is created. Code Cell 8, running Usher. Let's run this. This builds a tree with Usher, saving it as phylogenetic_tree_aligned_sequences.nwk. It takes around 2 minutes. Tree is completed. Let's check the phylogenetic_tree folder. These are the files created by Usher. IQ-Tree. IQ-Tree uses maximum likelihood for accurate trees. Let's run it. Code Cell 9, setting up directory for IQ-Tree. Let's run this. This creates data/COV/phylogenetic_tree/IQ-Tree. Directory is created. Here's the folder. Code Cell 10, running IQ-Tree. This runs IQ-Tree with the GTR plus G model and 1000 bootstraps. Let's execute it. This will take around 19 minutes. Tree completed in about 19 minutes. Tools: FastTree. FastTree generates quick approximate maximum likelihood trees. Code Cell 11, setting up directory for FastTree. Let's execute this. This creates a FastTree folder in the directory data/COV/phylogenetic_tree. Directory created. Here's the folder. Code Cell 12, running FastTree. Let's execute this. This runs FastTree, saving the output to aligned_sequences.nwk. It takes a few minutes. While that's running, let's discuss the summary. That's Submodule 3. We aligned sequences with MAFFT and built trees using Nextclade, Usher, IQTree, and FastTree. Outputs are ready for visualization in Submodule 4. Interactive quiz. Let's test our knowledge with a quiz on alignment and tools. While it takes some time to load because FastTree is running, the quiz will load after it completes. Finally, FastTree ran successfully. Let's look inside the FastTree folder. The output file has been generated, and the quiz has also loaded. Here are the questions. Pause it and solve them.